Imagine a sky not like ours, where not one, not two, but 7 worlds dance around a single star. This isn't a scene from a science fiction movie. It's real, and it's happening right now, just 40 light-years away. The TRAPPIST-1 system is a cosmic wonder, a treasure trove of planets that could hold the secrets to life beyond Earth. Each of these 7 worlds is unique, with some potentially hiding vast oceans beneath their surfaces. This is a place where the line between science and imagination blurs, and the possibilities are as endless as the cosmos itself. Stick around, because we're about to embark on an interstellar journey to explore these enigmatic worlds. The discovery of TRAPPIST-1, nestled in the constellation of Aquarius, about 40 light-years from Earth, lies the TRAPPIST-1 system, a celestial jewel box of 7 Earth-sized planets orbiting a single, dim red dwarf star. The story of its discovery is a testament to human curiosity and technological prowess. It all began with the TRAPPIST, Transiting Planets and Planetesimal Small Telescope project, a collaboration between European and American astronomers. They set out to find exoplanets using the transit method, watching for tiny dips in a star's brightness as a planet passes in front of it. The first 2 planets around TRAPPIST-1 were spotted in 2016, but the real surprise came the following year. A team led by Michael Gillen announced the discovery of 5 more Earth-sized planets, bringing the total to 7. This was unprecedented, a treasure trove of worlds to study, all within a single system. Each planet in the TRAPPIST-1 system is distinct, a mosaic of diverse worlds. The innermost planet, TRAPPIST-1b, is likely a rocky world with a surface temperature that could reach up to 500 degrees Fahrenheit, too hot for liquid water. Moving outward, TRAPPIST-1c and d are also likely rocky, with temperatures ranging from 300 to 200 degrees Fahrenheit. The 4th planet, TRAPPIST-1e, is the most Earth-like, with a radius only 5% larger than Earth's and a temperature that could allow for liquid water. TRAPPIST-1f, g, and h are also Earth-sized, with temperatures decreasing as you move outward. The outermost planet, TRAPPIST-1h, is likely icy, with a temperature around -300 degrees Fahrenheit. The planets are so close together that if you were to stand on one, the next planet would appear larger than the Moon does in our sky. The layout of the TRAPPIST-1 system is unlike anything we've seen before. All 7 planets orbit their star closer than Mercury orbits our Sun, with their orbits ranging from 1.5 to 12 days. Despite their proximity, the planets are in resonance, meaning their orbits are in a precise ratio to each other. This resonance is a clue to the system's past, suggesting that the planets migrated inward from a more distant orbit. The star itself, TRAPPIST-1, is an ultra-cool red dwarf, much smaller and cooler than our Sun. It's only about 8% of the mass of the Sun, with a surface temperature of around 500 degrees Fahrenheit. Despite its small size, it's a long-lived star, with an estimated lifespan of trillions of years. This longevity, combined with the abundance of Earth-sized planets, makes the TRAPPIST-1 system a prime target in the search for life beyond our solar system. The discovery of this system has opened a new chapter in our understanding of the universe, a chapter filled with the promise of diverse worlds and the potential for life. A star like no other. Nestled in the constellation Aquarius, about 40 light-years from Earth, lies the TRAPPIST-1 system, a celestial wonder that has captivated astronomers and space enthusiasts alike. At the heart of this system is an ultra-cool red dwarf star, a type of star that is much smaller and cooler than our Sun. This star, TRAPPIST-1, is so diminutive that it's only slightly larger than the planet Jupiter, yet it hosts a remarkable 7 Earth-sized planets, 3 of which are in the habitable zone where liquid water could potentially exist. The star's dimness and cool temperature mean that its habitable zone is much closer to it than the one around our Sun, leading to tightly packed orbits for its planets. The planets orbiting TRAPPIST-1 are a diverse bunch, each with its own unique characteristics. The innermost planet, TRAPPIST-1b, is likely tidally locked, meaning one side perpetually faces the star while the other remains in eternal night. Moving outward, TRAPPIST-1c and TRAPPIST-1d are also in the close vicinity of the star, with the latter being of particular interest due to its potential to harbor liquid water. TRAPPIST-1e is another standout, as it is the most Earth-sized of all the planets and is also within the habitable zone. The remaining planets, TRAPPIST-1f, G, and H, are progressively farther from the star, with the outermost planet, TRAPPIST-1h, being the least understood due to its distance and the limitations of current observational technology. The layout of the TRAPPIST-1 system is nothing short of astonishing. All 7 planets orbit their star in a tightly packed configuration, with the distance between the orbits of TRAPPIST-1b and TRAPPIST-1c being comparable to the distance between the Earth and the Moon. This close proximity means that the planets likely exert significant gravitational influences on each other, leading to complex orbital dynamics and potential tidal heating. The system's compact nature also makes it an ideal candidate for detailed study, as the planets pass in front of their star from our perspective, allowing astronomers to gather valuable data about their atmospheres and compositions. The excitement surrounding this system is palpable, as each new discovery brings us one step closer to understanding the potential for life beyond our solar system. The transit method, a dance of light and shadow. In the vast, dark ballet of the cosmos, the TRAPPIST-1 system performs an enthralling dance of light and shadow. At the heart of this celestial waltz is an ultra-cool red dwarf star, around which 7 Earth-sized planets pirouette. This dance is not merely a spectacle. It's a cosmic phenomenon that has captivated astronomers and ignited imaginations. The transit method, a technique used to detect exoplanets, has been instrumental in revealing the secrets of this remarkable system. When a planet transits or passes in front of its star, it causes a tiny, periodic dimming of the star's light. This flicker, though subtle, is a celestial whisper that speaks volumes about the planet's size, orbit, and even potential atmosphere. Each of the 7 TRAPPIST-1 planets has its own unique characteristics, making them a diverse ensemble in this interstellar performance. The innermost planet, TRAPPIST-1b, is a scorching world that completes an orbit in just 1.5 Earth days. Moving outward, TRAPPIST-1c and d are also likely too hot for life as we know it, with surface temperatures ranging from 232 to 400 degrees Fahrenheit. However, the story changes with TRAPPIST-1e, f, and g. These planets reside in the habitable zone, where liquid water could potentially exist on their surfaces. TRAPPIST-1e is the most Earth-sized of the bunch, with a radius only 5% larger than our home planet. TRAPPIST-1f is a bit larger, with a 10% radius increase, and TRAPPIST-1g is the largest of the 7, with a radius 13% greater than Earth's. The outermost planets, TRAPPIST-1h, is an icy world with an orbit that takes around 20 Earth days to complete. The layout of the TRAPPIST-1 system is a tightly packed, harmonious arrangement. All 7 planets orbit their star in a compact region, with their distances from the star ranging from 1.5 to 10 times the distance between Earth and the Sun. This close-knit configuration is a stark contrast to our own solar system, where planets are spread out over much greater distances. The proximity of the TRAPPIST-1 planets to each other and their star means that they are likely tidally locked, with one side perpetually facing the star and the other in eternal night. This peculiarity adds another layer of intrigue to the system, as it raises questions about the nature of their atmospheres, climates, and potential for life. The transit method has not only revealed the existence of these 7 worlds, but also provided tantalizing clues about their atmospheres. By analyzing the starlight that filters through a planet's atmosphere during a transit, scientists can detect the presence of specific gases. This technique, known as transmission spectroscopy, has been used to study the atmospheres of some of the TRAPPIST-1 planets. While the results are still preliminary, they suggest that some of these worlds may have atmospheres rich in water vapor, methane, or other intriguing compounds. The prospect of uncovering more about these atmospheres has astronomers on the edge of their seats, eager to learn whether any of these planets could harbor the ingredients for life. The TRAPPIST-1 system, with its dance of light and shadow, continues to captivate and inspire, offering a glimpse into the diverse and wondrous worlds that exist beyond our solar system. 7 shadows, 7 worlds. Nestled in the constellation of Aquarius, about 40 light-years from Earth, lies the TRAPPIST-1 system, a celestial marvel that has captivated astronomers and space enthusiasts alike. At the heart of this system is an ultra-cool red dwarf star, around which orbit 7 Earth-sized planets, each casting its own shadow in the starlight. These planets, named TRAPPIST-1b through TRAPPIST-1h, are arranged in a tightly packed configuration, with their orbits closer to their star than Mercury is to our Sun. This proximity results in orbital periods ranging from just 1.5 days for the innermost planet to about 20 days for the outermost, creating a mesmerizing dance of celestial bodies. Each of the 7 worlds possesses unique characteristics that make them fascinating subjects of study. The planets are likely tidally locked, meaning one side perpetually faces the star, bathed in perpetual daylight, while the other remains in eternal night. This creates a stark contrast in temperature and potential conditions between the 2 hemispheres. The innermost planets, B and C, are likely too hot to support life as we know it, with surface temperatures that could be inhospitable. However, planets D, E, F, and G reside within the habitable zone, where liquid water could potentially exist on their surfaces, making them prime candidates in the search for extraterrestrial life. Planet H, the outermost, is more distant and cooler, adding another layer of intrigue to the system. The TRAPPIST-1 system offers a unique opportunity to study planetary formation and evolution around a red dwarf star. These stars are the most common type in the Milky Way, making the TRAPPIST-1 system a valuable case study for understanding the potential habitability of such systems. The planets' close proximity to each other also means they may have influenced each other's formation and evolution, providing insights into planetary dynamics. Moreover, the system's relative closeness to Earth makes it an ideal target for further observation and study, with upcoming telescopes and missions poised to reveal even more about these enigmatic worlds. The discovery of the TRAPPIST-1 system has ignited a sense of excitement and wonder, reminding us of the vast possibilities that lie beyond our solar system. The innermost world, TRAPPIST-1b. Nestled in a quiet corner of the constellation Aquarius, approximately 39 light-years from Earth, lies the TRAPPIST-1 system. This compact cosmic ensemble is a treasure trove of celestial bodies, with 7 Earth-sized planets orbiting a single ultra-cool red dwarf star. The star, TRAPPIST-1, is a mere fraction of the Sun's size and mass, yet it hosts a remarkable family of worlds. Each planet is an enigma, a puzzle piece in the grand tapestry of this alien solar system. The innermost of these worlds, TRAPPIST-1b, is a tantalizing subject of study, offering a glimpse into the diverse environments that might exist within this remarkable system. TRAPPIST-1b is the closest planet to its star, orbiting at a distance of just 0.11 astronomical units, AU, which is about 1.6 million kilometers. To put that into perspective, Mercury, the innermost planet in our solar system, orbits the Sun at a distance of about 0.39 AU, or roughly 58 million kilometers. Despite its proximity to TRAPPIST-1, the planet's surface temperature is a subject of debate. The star's luminosity is feeble compared to our Sun, so even though TRAPPIST-1b is close, it doesn't receive much heat. Estimates suggest that the planet's equilibrium temperature, the temperature it would be without any atmosphere, is around 400 Kelvin, 127 degrees Celsius, or 260 degrees Fahrenheit. However, the actual temperature could be different if the planet has an atmosphere that traps heat. The nature of TRAPPIST-1b's atmosphere, if it exists, is one of the many mysteries surrounding this world. Observations have not yet provided definitive evidence of an atmosphere, but the possibility remains open. If an atmosphere does exist, it could be vastly different from Earth's. The planet's close proximity to its star means it is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. This would create extreme temperature gradients, with one side potentially hot enough to vaporize rocks and the other cold enough to freeze them. Such conditions could lead to a dynamic atmosphere, with strong winds circulating between the two hemispheres. The study of TRAPPIST-1b and its siblings offers a unique opportunity to explore the diversity of planetary systems. Each world in the TRAPPIST-1 system is a potential goldmine of scientific discovery. The innermost planet, with its extreme conditions, provides a stark contrast to the more temperate worlds further out. The data collected from these planets could reshape our understanding of planetary formation, evolution, and habitability. As our telescopes grow more powerful and our techniques more refined, the TRAPPIST-1 system beckons, promising to reveal its secrets and expand the boundaries of our knowledge. A scorching embrace, TRAPPIST-1b's environment. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a captivating celestial dance of 7 planets orbiting a cool, dim red dwarf star. This star, TRAPPIST-1, is a mere fraction of the Sun's size and mass, making it a tiny, luminous ember in the vast cosmic night. The planets, all roughly Earth-sized, are packed close together, their orbits a complex, interwoven tapestry. This proximity means that they are tidally locked, always presenting the same face to their star, much like the Moon does to Earth. The innermost planet, TRAPPIST-1b, is the first in this celestial waltz, completing an orbit in just 1.5 Earth days. TRAPPIST-1b is a world of extremes, bathed in the relentless embrace of its star. The side perpetually facing TRAPPIST-1 is a scorching inferno, with temperatures potentially high enough to vaporize rock. The other side, in contrast, is a frigid, dark expanse, possibly colder than the farthest reaches of Pluto. The thin line between these two extremes is a twilight zone, a narrow band where temperatures might be more temperate. This zone is a tantalizing prospect for scientists, a potential haven where liquid water could exist and life, as we know it, might cling on. The environment of TRAPPIST-1b is a study in contrasts, a world where the line between habitability and inhospitability is blurred. The planet's proximity to its star means it is bombarded with intense radiation and stellar winds, stripping away any atmosphere it might have. This constant barrage could have long ago swept away any water or atmosphere, leaving behind a barren, rocky surface. Yet, the possibility of a thin atmosphere on the night side, shielded from the star's wrath, cannot be entirely ruled out. This tantalizing prospect keeps scientists guessing, their curiosity piqued by the enigmatic nature of this scorching world. Despite its harsh conditions, TRAPPIST-1b is a crucial piece of the puzzle in understanding the TRAPPIST-1 system and exoplanets in general. Its study provides valuable insights into planetary formation, evolution, and the potential for life in the universe. The system's relative proximity to Earth makes it a prime target for further investigation, with the James Webb Space Telescope and future observatories poised to unravel its mysteries. Each planet in this system, including TRAPPIST-1b, is a world unto itself, a testament to the incredible diversity and complexity of the cosmos. The TRAPPIST-1 system is more than just a collection of planets. It's a cosmic laboratory, a place where the boundaries of our understanding are pushed and the excitement of discovery is palpable. The second realm, TRAPPIST-1c. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a captivating celestial ensemble that has astronomers and dreamers alike buzzing with excitement. At the heart of this system is an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets in a tightly packed orbital dance. The second planet from the star, TRAPPIST-1c, is a world that defies our terrestrial norms and invites us to stretch our imaginations. TRAPPIST-1c is a rocky planet, similar in size and composition to Earth, but its environment is likely vastly different. Orbiting its star every 2.4 days, TRAPPIST-1c is in a tight embrace with TRAPPIST-1, receiving about twice the amount of radiation that Earth gets from the Sun. This intense stellar embrace means that TRAPPIST-1c is probably tidally locked, with one side perpetually facing the star, bathed in perpetual daylight, while the other side remains in eternal night. The boundary between these two realms, known as the terminator line, could be a place of mild temperatures, where conditions might be just right for liquid water to exist. The star system's layout is a marvel of cosmic geometry. All 7 planets orbit TRAPPIST-1 in a compact, resonant system, where each planet's orbit is in harmony with its neighbors. This resonance means that their gravitational influences keep the system stable, like a carefully choreographed dance. TRAPPIST-1c, being the second in line, plays a crucial role in this dance, its gravity influencing the orbits of both its inner and outer neighbors. This interconnectedness makes the system a fascinating subject for study, offering insights into planetary formation and stability. The excitement surrounding the TRAPPIST-1 system stems from the potential for habitability. While TRAPPIST-1c itself is likely too hot to be habitable, its proximity to the habitable zone and its role in the system's dynamics make it a key player in our understanding of these worlds. The system's sheer number of Earth-sized planets offers a unique opportunity to study a diversity of planetary environments, all within a single star system. This is a treasure trove for astronomers, a playground for scientists, and a source of endless fascination for those who gaze up at the night sky and wonder what else is out there. A balancing act, TRAPPIST-1c's position. Nestled in the constellation of Aquarius, approximately 40 light-years from Earth, the TRAPPIST-1 system has captivated astronomers and space enthusiasts alike. At its heart lies an ultra-cool red dwarf star, around which orbit 7 Earth-sized planets, 3 of which are located within the habitable zone. This remarkable system, with its tightly packed planets, offers a unique opportunity to study planetary formation and evolution, as well as the potential for life beyond our solar system. The star's dimness and the planet's close proximity to it create a delicate dance of gravitational forces, making the TRAPPIST-1 system a fascinating subject of study. TRAPPIST-1c, the second planet from the star, is a pivotal player in this celestial ballet. It is slightly larger than Earth, with a radius about 1.9 times that of our home planet. Its orbit is a mere 2.4 days, a stark contrast to Earth's 365-day journey around the Sun. This proximity to the star means that TRAPPIST-1c is likely tidally locked, with one side perpetually facing the star and the other shrouded in eternal night. The planet's position makes it a crucial subject for understanding the dynamics of the entire system. Its gravitational influence plays a significant role in stabilizing the orbits of its neighboring planets, particularly TRAPPIST-1b and TRAPPIST-1d. The TRAPPIST-1 system's layout is a testament to the wonders of planetary formation. The 7 planets are so close to each other that, from the surface of one, the neighboring planets would appear as large as the Moon or even larger in the sky. This proximity has led to a complex interplay of gravitational forces, with each planet exerting a noticeable influence on its neighbors. The system's compact nature also means that the planets' orbits are closely aligned, a configuration known as orbital resonance. This resonance helps to stabilize the system, preventing the planets from colliding or being ejected into space. The TRAPPIST-1 system's unique characteristics make it an invaluable subject for studying planetary dynamics and the potential for life in other star systems. TRAPPIST-1c's position in this system is a delicate balancing act. Its gravitational pull helps to maintain the stability of the orbits of its neighboring planets, while its own orbit is influenced by the gravitational forces of the other planets. This interplay of forces is a crucial factor in the system's long-term stability. The planet's tidally locked state also raises intriguing questions about its potential habitability. While the side facing the star would be too hot for life as we know it, the terminator line, the boundary between the day and night sides, could potentially harbor conditions suitable for life. The study of TRAPPIST-1c and its neighbors offers a unique opportunity to explore the possibilities of life in other star systems and to deepen our understanding of planetary formation and evolution. The third world, TRAPPIST-1d, nestled in the constellation of Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a treasure trove of celestial wonders. At its heart lies an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets, 3 of which orbit within the habitable zone. This tight-knit family of worlds is a sight to behold, with their orbits so close that from the surface of one, the neighboring planets would appear as large as the Moon does to us. The third planet from the star, TRAPPIST-1d, is particularly intriguing, orbiting at a distance where temperatures might allow for liquid water to exist on its surface. TRAPPIST-1d is slightly larger than Earth, with a radius about 70% of greater, and it completes an orbit around its star in just about 4 days. Despite its proximity to the star, the planet receives about 4.3 times the amount of radiation that Earth gets from the Sun. This is due to the star's relative coolness and the planet's close orbit. The planet's density is similar to Earth's, suggesting a rocky composition. It's tidally locked, meaning one side perpetually faces the star, while the other remains in eternal night. This creates a unique and dramatic environment, with a perpetual day side and night side, and a twilight zone in between where temperatures might be just right for liquid water. The atmosphere of TRAPPIST-1d is a subject of great interest. Observations suggest that it may have a thick atmosphere, possibly rich in water vapor, which could create a greenhouse effect, trapping heat and potentially allowing for liquid water on the surface. The planet's location within the habitable zone makes it a prime candidate in the search for extraterrestrial life. Scientists are eager to study its atmosphere more closely, using advanced telescopes and future missions to look for biosignatures or signs of life. The discovery of such signatures would be a monumental step in our understanding of life in the universe. A glimpse of potential, TRAPPIST-1d's habitability. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system has captivated astronomers and space enthusiasts alike. At the heart of this system is an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets in a tightly packed orbital dance. The planets, named TRAPPIST-1b to TRAPPIST-1h, orbit their star in a compact configuration, with their distances ranging from 1.5 to 12 times the distance between Earth and the Sun. This close-knit arrangement allows for a synchronized gravitational interaction, leading to a phenomenon known as orbital resonance, where the planet's orbits are locked in a rhythmic pattern. Among these 7 worlds, TRAPPIST-1d stands out as a prime candidate for habitability. Located within the star's habitable zone, the region where liquid water could potentially exist on the surface, TRAPPIST-1d receives a moderate amount of stellar radiation. This planet is roughly 2.8 times the mass of Earth, suggesting a rocky composition with a possible atmosphere. Its orbit around the star takes about 4 days, a stark contrast to Earth's 365-day journey. The proximity to its star means that TRAPPIST-1d is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. However, the presence of an atmosphere could distribute heat more evenly, potentially creating a habitable zone on the planet's surface. The excitement surrounding TRAPPIST-1d's habitability stems from its potential to harbor liquid water, a crucial ingredient for life as we know it. Recent studies have suggested that the planet might have a substantial amount of water, possibly in the form of oceans or ice. The star's cool temperature and the planet's close orbit mean that TRAPPIST-1d receives about 4.3 times the amount of radiation that Earth gets from the Sun. This could result in a surface temperature range that allows for liquid water, provided the planet has the right atmospheric conditions. The discovery of multiple planets in the habitable zone of a single star system, like TRAPPIST-1, raises intriguing possibilities about the prevalence of potentially habitable worlds in our galaxy. Moreover, the TRAPPIST-1 system offers a unique opportunity to study planetary atmospheres and compositions in detail. The James Webb Space Telescope, JWST, launched in 2021, is poised to revolutionize our understanding of these distant worlds. By analyzing the light that passes through the planet's atmospheres during transits, scientists can identify the chemical signatures of various gases, including water vapor, methane, and carbon dioxide. These observations could provide critical insights into the atmospheric composition and potential habitability of TRAPPIST-1d and its neighboring planets. The prospect of finding signs of life, even in its most basic forms, adds a layer of thrill to the exploration of this remarkable star system. The fourth world, TRAPPIST-1e. Nestled in a quiet corner of the constellation Aquarius, about 40 light-years from Earth, lies the TRAPPIST-1 system. This compact cosmic neighborhood is home to 7 Earth-sized planets, all orbiting a star that's a mere fraction of the size of our Sun. The star, TRAPPIST-1, is an ultra-cool red dwarf, a type of star that's dimmer and cooler than our Sun. Despite its modest size, this star hosts a remarkable planetary system, with 3 of its worlds, TRAPPIST-1e, F, and G, residing in the habitable zone, where liquid water could potentially exist on their surfaces. The fourth world, TRAPPIST-1e, is particularly intriguing. It's slightly more massive than Earth, with a radius about 92% of that of our home planet. This world completes an orbit around its star in just 6.1 Earth days, a stark contrast to our 365-day journey around the Sun. Despite its proximity to TRAPPIST-1, TRAPPIST-1e receives a similar amount of stellar energy as Earth does from the Sun. This balance makes it a prime candidate in the search for habitable worlds beyond our solar system. The planet's density suggests that it's likely a rocky world, much like Earth, Venus, or Mars. However, the composition of its atmosphere remains a mystery, a tantalizing enigma for astronomers to unravel. The TRAPPIST-1 system is a tightly knit family of planets. The 7 worlds are so close to each other that if you were to stand on the surface of one, you might see the others as large, nearby moons in the sky. This proximity has fascinating implications for the planet's atmospheres and potential habitability. For instance, the gravitational interactions between the planets could lead to tidal heating, a process that might drive geological activity and contribute to a planet's habitability. Moreover, the planet's orbits are in resonance, meaning that their orbital periods are in precise ratios to each other. This resonance is a testament to the system's stability and could provide clues about its formation and evolution. TRAPPIST-1e's position in the habitable zone, its Earth-like size, and its potential for geological activity make it a compelling target for further study. Astronomers are eager to probe its atmosphere for signs of biosignatures, chemicals that could indicate the presence of life. The James Webb Space Telescope, set to launch soon, will be a powerful tool in this endeavor. It will be able to analyze the light filtering through the planet's atmospheres, providing valuable insights into their compositions. The TRAPPIST-1 system, with its 7 worlds and tantalizing possibilities, is a treasure trove of scientific potential. Each planet, including TRAPPIST-1e, is a piece of the puzzle in our quest to understand our place in the cosmos. A rocky haven, TRAPPIST-1e's composition. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a treasure trove of celestial bodies. At its heart lies an ultra-cool dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets in a tightly packed orbital dance. This star, TRAPPIST-1, is a mere 12 times the diameter of Jupiter, making it much smaller and cooler than our Sun. The planets, named TRAPPIST-1b through TRAPPIST-1h, orbit their star in a compact configuration, with their distances ranging from 1.5 to 12 times the distance between Earth and the Moon. This proximity allows for a synchronized gravitational interaction, causing tidal forces that could potentially drive geological activity and maintain habitable conditions. Among these 7 worlds, TRAPPIST-1e stands out as a rocky haven, a planet with a composition remarkably similar to Earth. With a radius roughly 92% of that of our home planet, TRAPPIST-1e is likely to be rocky, with a dense, metallic core. Its mass is estimated to be around 77% of Earth's, suggesting a similar density and composition. The planet orbits within the habitable zone of its star, where temperatures could allow for liquid water to exist on its surface. This makes TRAPPIST-1e a prime candidate in the search for extraterrestrial life. The planet's atmosphere, if it exists, could provide clues about its potential habitability. Scientists are eager to study this world further, as it represents one of the best opportunities to explore the conditions necessary for life beyond our solar system. The TRAPPIST-1 system is a fascinating laboratory for studying planetary formation and evolution. The planets are so close to each other that they exert significant gravitational influences, leading to complex orbital dynamics. This proximity also means that each planet is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. However, the presence of an atmosphere could help distribute heat, potentially creating a more temperate environment. The system's compact nature makes it an ideal target for future telescopes and space missions, which could provide detailed insights into the atmospheres and surfaces of these alien worlds. The discovery of the TRAPPIST-1 system has ignited a sense of excitement and wonder, as it offers a unique opportunity to explore multiple Earth-sized planets around a single star. Each planet, with its unique characteristics and potential for habitability, adds to the allure of this extraordinary system. The fifth world, TRAPPIST-1f. Nestled in a quiet corner of the constellation Aquarius, the TRAPPIST-1 system is a treasure trove of celestial wonders. At its heart lies a dim, cool star, a mere fraction of the sun's size, yet it's a beacon of hope for astronomers. This unassuming star hosts a family of 7 Earth-sized planets, a record in our galaxy. Each world is an enigma, a puzzle piece in the grand tapestry of planetary science. Among these, the fifth world, TRAPPIST-1f, stands out, a potential oasis in the cosmic desert. TRAPPIST-1f is a rocky planet, much like our own, but its similarities to Earth might end there. It's about 10% larger than Earth, making it a super-Earth in astronomical terms. Its mass is roughly 60% greater than Earth's, suggesting a denser composition. The planet orbits its star at a distance that places it within the habitable zone, where temperatures could allow for liquid water to exist on its surface. This is the sweet spot, the Goldilocks zone, not too hot, not too cold, but just right for life as we know it. The TRAPPIST-1 system is a tightly knit family, with all 7 planets orbiting their star in a compact disk, much smaller than Mercury's orbit around the Sun. The planets are so close together that if you were to stand on the surface of one, you might see the others as large moons in the sky, their features visible in stark detail. TRAPPIST-1f, being the 5th planet, enjoys a 9-day orbit around its star. This proximity means it's likely tidally locked, with one side perpetually facing the star, bathed in eternal daylight, while the other remains in constant night. The terminator, the line between day and night, could be a temperate band where life might find a foothold. The excitement surrounding TRAPPIST-1f and its siblings is palpable. Each planet is a potential goldmine of scientific discovery. They offer a unique opportunity to study planetary systems in unprecedented detail. The planets' proximity to each other and their star means that they perturb each other's orbits, providing a wealth of data for astronomers to unravel the mysteries of their compositions, atmospheres, and potential habitability. TRAPPIST-1f, with its position in the habitable zone, is a prime candidate in the search for extraterrestrial life. It's a beacon of hope, a testament to the incredible diversity of worlds that exist beyond our solar system. A water world, TRAPPIST-1f's possible oceans. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a treasure trove of celestial wonders. At its heart lies an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts a remarkable family of 7 Earth-sized planets. These worlds, named TRAPPIST-1b through TRAPPIST-1h, orbit their star in a tightly packed configuration, with their sizes and masses remarkably similar to those of the terrestrial planets in our own solar system. The proximity of these planets to their star and to each other makes this system a fascinating subject for astronomers and exoplanet enthusiasts alike. Among these 7 worlds, TRAPPIST-1f stands out as a particularly intriguing candidate for harboring life. Located within the habitable zone of the TRAPPIST-1 system, this planet receives a similar amount of stellar radiation as Earth does from the Sun. This positioning suggests that temperatures on TRAPPIST-1f could allow for the existence of liquid water on its surface. With a radius only about 10% larger than Earth's, TRAPPIST-1f is also likely to have a rocky composition, further enhancing its potential for hosting oceans. The planet's density indicates that it could have a significant amount of water, possibly in the form of surface oceans or subsurface reservoirs. The possibility of oceans on TRAPPIST-1 is not just a matter of speculation. Observations using the Hubble Space Telescope and other advanced instruments have provided tantalizing clues about the planet's atmosphere and surface conditions. While direct evidence of water is still elusive, the data suggests that TRAPPIST-1 could have a relatively thick atmosphere, which would be crucial for maintaining liquid water on its surface. Additionally, the planet's location within the habitable zone means that it could experience a stable climate, with temperatures ranging from 200 to 270 Kelvin, 73 to 3 Celsius, making it a prime candidate for further study. The excitement surrounding TRAPPIST-1 is not just about the potential for water. The planet's proximity to its star and its siblings means that it could be subject to complex tidal forces and atmospheric interactions. These dynamic conditions could create a rich tapestry of environmental processes, from volcanic activity to weather patterns, that might support a diverse range of chemical reactions and potentially even life. As our understanding of the TRAPPIST-1 system deepens, so too does our appreciation for the incredible diversity and potential of exoplanetary systems. The quest to uncover the secrets of TRAPPIST-1 and its possible oceans is not just a scientific endeavor. It's a journey into the heart of one of the most captivating mysteries of our universe. The sixth world, TRAPPIST-1. Nestled in a tightly packed system, TRAPPIST-1 is the sixth planet orbiting its cool, dim star. It's part of a remarkable ensemble of 7 worlds, all nestled closer to their star than Mercury is to our Sun. This proximity creates a unique dynamic, with each planet potentially influencing the others. TRAPPIST-1 is no exception, playing a crucial role in this celestial ballet. It's a world that has piqued the interest of astronomers and enthusiasts alike, not just for its position in the system, but also for its potential to harbor conditions suitable for life. TRAPPIST-1 is a rocky planet, similar in size and density to Earth. It's about 1.13 times the radius of our home planet, making it one of the larger worlds in the TRAPPIST-1 system. Its mass is roughly 1.14 times that of Earth, suggesting a similar composition. What sets TRAPPIST-1 apart is its location within the habitable zone of its star. This is the region where temperatures could allow for liquid water to exist on the surface, a key ingredient for life as we know it. However, the exact conditions on TRAPPIST-1 are still a subject of debate. The planet's atmosphere, if it exists, could play a significant role in determining its surface temperature and potential habitability. The TRAPPIST-1 system is a treasure trove of scientific discovery. All 7 planets orbit their star in a tightly packed configuration, with the outer planets like TRAPPIST-1 experiencing gravitational interactions with their neighbors. These interactions can lead to tidal heating, a process where gravitational forces stretch and compress the planet, generating heat. This could potentially drive geological activity on TRAPPIST-1, creating conditions suitable for life. Moreover, the planet's orbits are in resonance, meaning their orbital periods are related by a ratio of whole numbers. This resonance is a testament to the stability of the system, allowing the planets to maintain their orbits over billions of years. The excitement surrounding TRAPPIST-1 and its siblings stems from their potential to answer one of humanity's most profound questions. Are we alone in the universe? The discovery of 7 worlds orbiting a single star, with at least 3 potentially habitable, has opened up new avenues for exploration. TRAPPIST-1, with its Earth-like size and position within the habitable zone, is a prime candidate for further study. Future missions and advancements in technology may allow us to probe its atmosphere, search for biosignatures, and perhaps one day, answer the age-old question of whether life exists beyond Earth. The journey to uncover the secrets of TRAPPIST-1 and its siblings has only just begun, and with each new discovery, our understanding of the cosmos expands. A frozen orbit, TRAPPIST-1's icy expanse. Nestled in the constellation Aquarius, approximately 40 light-years from Earth, the TRAPPIST-1 system is a captivating celestial ensemble that has ignited the imagination of astronomers and space enthusiasts alike. At the heart of this system lies an ultra-cool red dwarf star, around which 7 Earth-sized planets orbit in a tightly packed configuration. The star's dim luminosity and the planet's close proximity to it create a unique dynamic, with each world potentially harboring conditions that could support life. The planets, designated TRAPPIST-1b through TRAPPIST-1h, exhibit a remarkable diversity in their characteristics, making this system a treasure trove for scientific exploration. TRAPPIST-1g, the 6th planet from the star, is a world shrouded in mystery and intrigue. Positioned within the habitable zone, where liquid water could theoretically exist, TRAPPIST-1g is a prime candidate in the search for extraterrestrial life. However, its exact nature remains elusive. With a radius roughly 1.13 times that of Earth, TRAPPIST-1g is likely a rocky planet, but its surface conditions are far from Earth-like. The planet's orbit, which takes about 12 days to complete, places it in a region where the star's radiation is significantly reduced. This results in a frozen orbit, with surface temperatures plummeting to potentially -90 degrees C, -130 degrees Fahrenheit, or lower. The icy expanse of TRAPPIST-1g is a stark contrast to the warmer, more hospitable conditions of its neighboring planets. The TRAPPIST-1 system's layout is a testament to the wonders of planetary formation and dynamics. The 7 planets orbit their star in a resonant chain, meaning their orbital periods are in near-integer ratios. This resonance is a delicate dance, with each planet's gravity influencing the others, creating a stable and synchronized system. The inner planets, TRAPPIST-1b through TRAPPIST-1d, are likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. TRAPPIST-1e, f, and h, including our icy expanse TRAPPIST-1g, occupy the habitable zone, each offering a unique perspective on the potential for life. The outermost planet, TRAPPIST-1h, is the least understood, with its orbit and characteristics still being unraveled. The excitement surrounding the TRAPPIST-1 system is palpable. Each planet presents a new puzzle, a new opportunity to understand the cosmos and our place within it. TRAPPIST-1g, with its frozen orbit and icy expanse, is a reminder of the diversity and complexity of planetary systems. It challenges our notions of habitability and pushes the boundaries of our search for life beyond Earth. As we continue to explore this remarkable system, we are not just uncovering the secrets of distant worlds. We are also learning more about our own planet and the delicate balance that sustains life. The TRAPPIST-1 system is a beacon of hope and discovery, a testament to the enduring human spirit of exploration and curiosity. The outermost world, TRAPPIST-1h, nestled in the constellation of Aquarius, about 40 light-years from Earth, lies the TRAPPIST-1 system, a captivating ensemble of 7 planets orbiting a small, cool star. This system has ignited the imagination of astronomers and space enthusiasts alike, offering a tantalizing glimpse into the potential diversity of planetary systems beyond our own. Among these worlds, the outermost planet, TRAPPIST-1h, holds a special allure, presenting a unique set of characteristics that set it apart from its siblings. TRAPPIST-1h is the 7th and farthest known planet from the star TRAPPIST-1, a mere 8% of the mass of our Sun. This diminutive star, classified as an ultra-cool dwarf, bathes its planets in a dim, reddish light, creating a stark contrast to the brilliant yellow of our Sun. The outermost world, TRAPPIST-1h, completes an orbit around its star roughly every 19 days. This rapid orbit is a testament to the close-knit nature of the TRAPPIST-1 system, where all 7 planets are packed within a distance equivalent to the orbit of Mercury around our Sun. Despite its proximity to the star, TRAPPIST-1h receives only a fraction of the stellar energy that Earth does, placing it in a region that might be too cold for liquid water to exist on its surface. The characteristics of TRAPPIST-1h are still shrouded in some mystery, as it is the least well-studied of the 7 planets. Initial observations suggest that it is likely a rocky world, similar in composition to the inner planets of our solar system. However, its exact size, mass, and atmospheric composition remain uncertain. What makes TRAPPIST-1 particularly intriguing is its position at the edge of the habitable zone, the region around a star where conditions could potentially allow for the existence of liquid water. While it is likely too cold for water to remain liquid on its surface, the possibility of subsurface oceans or a dense atmosphere that could trap heat and create a more temperate environment cannot be ruled out. This tantalizing prospect has fueled speculation about the potential habitability of TRAPPIST-1, adding to the excitement surrounding this enigmatic world. The TRAPPIST-1 system, with its 7 Earth-sized planets, offers a unique opportunity to study the dynamics of a compact planetary system. The planets are in a resonant chain, meaning their orbital periods are in near-integer ratios, a configuration that suggests a stable and orderly system. This resonance is thought to have arisen from a process of orbital migration and tidal interaction, where the planets moved inward from their formation locations and settled into their current orbits. The outermost world, TRAPPIST-1, plays a crucial role in this resonant chain, helping to maintain the stability of the system. Its presence ensures that the other planets remain in their resonant orbits, preventing chaotic interactions that could disrupt the system. This intricate dance of planets around their tiny star is a testament to the complexity and beauty of the TRAPPIST-1 system, a celestial ballet that continues to captivate astronomers and inspire further exploration. A distant wanderer, TRAPPIST-1's elusive nature. Nestled in the constellation of Aquarius, approximately 39 light-years from Earth, the TRAPPIST-1 system is a captivating celestial ensemble that has ignited the imagination of astronomers and space enthusiasts alike. At the heart of this system lies an ultra-cool red dwarf star, TRAPPIST-1, which is significantly smaller and cooler than our Sun. Orbiting this diminutive star is a tightly packed family of 7 Earth-sized planets, each with its own unique characteristics and mysteries. The planets, named TRAPPIST-1b through TRAPPIST-1, are in a resonant chain, meaning their orbital periods are in near-integer ratios, creating a harmonious cosmic dance. Among these 7 worlds, TRAPPIST-1 stands out as the most distant and elusive. It completes an orbit around its star every 18.77 days, placing it in the outer reaches of the system. Unlike its siblings, TRAPPIST-1 is likely too far from the star to harbor liquid water on its surface, making it a chilly and potentially inhospitable world. Its exact size and composition remain uncertain, adding to its enigmatic nature. The planet's distance from its star and the other planets in the system makes it a challenging target for detailed study, leaving much to the imagination. The TRAPPIST-1 system is a treasure trove of scientific potential. Each planet offers a unique opportunity to study the diversity of planetary systems and the conditions that might lead to the emergence of life. The inner planets, TRAPPIST-1b through TRAPPIST-1, are of particular interest due to their potential to host liquid water, a key ingredient for life as we know it. These planets are in the habitable zone, the region around a star where temperatures could allow for liquid water on the surface. The discovery of such a large number of Earth-sized planets in a single system has opened up new avenues for exploring the possibilities of life beyond our solar system. Despite its elusive nature, TRAPPIST-1 plays a crucial role in our understanding of the TRAPPIST-1 system. Its existence provides valuable insights into the formation and evolution of planetary systems. The resonant chain of the TRAPPIST-1 planets suggests a stable and long-lived system, which is a promising sign for the potential habitability of the inner planets. As our technology and observational techniques advance, we may one day uncover the secrets of TRAPPIST-1 and gain a deeper understanding of this fascinating system. The TRAPPIST-1 system, with its 7 worlds around a single star, is a testament to the wonders of our universe and the endless possibilities that await exploration. A symphony of resonances, the orbits of TRAPPIST-1. Nestled in the constellation of Aquarius, approximately 40 light-years from Earth, the TRAPPIST-1 system is a captivating celestial ensemble that has astronomers buzzing with excitement. At the heart of this system lies an ultra-cool red dwarf star, around which 7 Earth-sized planets pirouette in a mesmerizing dance of resonances. This stellar waltz is a symphony of gravitational interactions, where each planet's orbit is intricately linked to its neighbors, creating a harmonious rhythm that has captivated scientists and stargazers alike. The 7 planets, snugly packed within a distance equivalent to Mercury's orbit around our Sun, are labeled from B to H, in order of their increasing distance from the star. Each planet's characteristics are as diverse as the notes in a symphony. Planet B, the closest to the star, is likely a rocky world with a year lasting just 1.5 Earth days. Moving outward, Planet C and D are also rocky, with years of 2.4 and 4.1 days respectively. Planet E, with a 6.1-day year, is notable for being the most Earth-like in terms of size, density, and the amount of starlight it receives. Planet F, G, and H, with years of 9, 12, and 20 days respectively, are also rocky and could potentially host liquid water, given the right conditions. The true marvel of the TRAPPIST-1 system lies in the resonant orbits of its planets. This means that the planets' orbital periods are in precise integer ratios, creating a gravitational harmony that keeps their orbits stable. For instance, for every 8 orbits that Planet B completes, Planet C orbits 5 times, and Planet D orbits 3 times. This 8:5:3 resonance is just one example of the intricate dance that plays out in this system. Such resonances are not just mathematical curiosities. They provide insights into the system's formation and evolution. They also offer clues about the planet's compositions and atmospheres, which could be crucial in the search for habitable worlds. The TRAPPIST-1 system, with its symphony of resonances and diverse worlds, is a testament to the incredible variety and beauty of our universe. Tidal forces, a dance of gravity and time. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a marvel of cosmic architecture. At its heart lies an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets in a tightly packed orbital dance. The planets, labeled TRAPPIST, 1b through TRAPPIST, 1h, orbit their star in a synchronized ballet, with some taking just a few days to complete a revolution. This proximity means the planets are likely tidally locked, always presenting the same face to their star, much like the Moon does to Earth. The innermost planets, B and C, are likely scorching hot, while the outer ones, G and H, might be icy. Planet E, however, sits right in the habitable zone, where liquid water could exist. Tidal forces in the TRAPPIST-1 system are a testament to the ceaseless dance between gravity and time. These forces arise from the gravitational pull of the star on each planet, and vice versa, creating a dynamic interplay that can heat the planet's interiors and drive geological activity. For instance, the same forces that cause ocean tides on Earth can generate friction within the planets, leading to internal heating. This process, known as tidal heating, could potentially create subsurface oceans on some of the outer planets, even if their surfaces are frozen. The planets' orbits are also not perfectly circular, which means their distances from the star vary, leading to changes in the tidal forces they experience. This variation could result in a rhythmic expansion and contraction of the planets, further contributing to internal heating. Each planet in the TRAPPIST-1 system has its unique characteristics, shaped by its position and the tidal forces at play. The innermost planet, B, experiences the strongest tidal forces, likely making it a hot, geologically active world. Planet C, slightly farther out, might have a more temperate climate, with possible oceans and a thicker atmosphere. Planet D, on the other hand, is likely a water world, with a global ocean beneath a steamy atmosphere. Planet E, the most Earth-like of the bunch, could have a diverse range of environments, from vast oceans to expansive landmasses. The outer planets, F, G, and H, are more mysterious. They might be icy worlds with subsurface oceans, or perhaps even more exotic environments, waiting to be explored. The TRAPPIST-1 system is a treasure trove of scientific potential. Its proximity to Earth makes it an ideal target for further study, particularly with the upcoming James Webb Space Telescope, which will be able to analyze the atmospheres of these planets. The system's unique architecture offers a natural laboratory for studying the effects of tidal forces on planetary evolution. Moreover, the possibility of habitable worlds within the system has sparked excitement among scientists and the public alike. The TRAPPIST-1 system is a reminder of the incredible diversity of planetary systems in our universe and the tantalizing possibilities that await us among the stars. The Goldilocks zone, a quest for habitability. Nestled in the constellation Aquarius, about 40 light-years from Earth, lies the TRAPPIST-1 system, a captivating celestial arrangement that has ignited the imagination of astronomers and space enthusiasts alike. At the heart of this system is an ultra-cool red dwarf star, around which orbit 7 Earth-sized planets. What makes this system particularly thrilling is the fact that 3 of these planets, TRAPPIST-1e, F, and G, reside within the star's habitable zone, often referred to as the Goldilocks zone. This is the orbital region where conditions might be just right for liquid water to exist on a planet's surface, a crucial ingredient for life as we know it. Each of the 7 planets in the TRAPPIST-1 system is distinct, offering a tantalizing array of possibilities. The innermost planet, TRAPPIST-1b, is likely too close to the star, with surface temperatures probably too high for liquid water. TRAPPIST-1c, the second planet, is a bit farther out, but still likely too hot. TRAPPIST-1d, the third planet, is on the edge of the habitable zone and could potentially host liquid water, depending on its atmospheric conditions. Then come the trio of planets E, F, and G, which are smack dab in the middle of the habitable zone. TRAPPIST-1e is slightly smaller than Earth, with a density suggesting a rocky composition. TRAPPIST-1f is a bit larger and could be a water world, with a substantial amount of its mass made up of water. TRAPPIST-1g, the largest of the 7, is also likely rocky and could have a dense atmosphere. The outermost planets, TRAPPIST-1h, is probably too cold for liquid water, but its atmosphere could still hold some surprises. The layout of the TRAPPIST-1 system is unlike anything we've seen in our own solar system. All 7 planets orbit their star in a tightly packed configuration, with the distance between the innermost and outermost planets being smaller than the distance between Mercury and the Sun. This close proximity means that the planets likely experience strong tidal forces, which could lead to tidal heating and geological activity. Moreover, the planets are likely tidally locked, meaning they always present the same face to their star, much like how the Moon always shows the same side to Earth. This could result in extreme temperature differences between the day and night sides, although a thick atmosphere could help to distribute heat more evenly. The discovery of the TRAPPIST-1 system has opened up a treasure trove of possibilities for the search for extraterrestrial life. With 3 planets in the habitable zone, the chances of finding conditions suitable for life are significantly higher than in systems with only 1 potentially habitable planet. Furthermore, the system's relative proximity to Earth makes it a prime target for future observation and study. As our understanding of this fascinating system grows, so too does our excitement about the potential to uncover the secrets of life beyond our own planet. The TRAPPIST-1 system is a testament to the incredible diversity of planetary systems in our universe and a beacon of hope in our quest to find habitable worlds. Atmospheres, the breath of life. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a treasure trove of celestial bodies. At its heart lies an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets in a tightly packed orbital dance. 3 of these worlds, TRAPPIST-1e, F, and G, reside in the habitable zone, where conditions might allow for liquid water to exist on their surfaces. The system's compact nature means that the planets are close to each other, with some having years that last only a few Earth days. This proximity raises intriguing possibilities for atmospheric interactions and shared influences. Each planet in the TRAPPIST-1 system boasts unique characteristics that make them fascinating subjects of study. TRAPPIST-1b, the innermost planet, is likely tidally locked, with one side perpetually facing the star and the other shrouded in darkness. Its atmosphere, if it exists, would be subject to extreme temperature gradients. Moving outward, TRAPPIST-1c and D present more moderate conditions, with potential atmospheres that could harbor complex chemistry. TRAPPIST-1e, often highlighted for its Earth-like size and density, might possess a thin atmosphere, making it a prime candidate for further exploration. The outer planets, F, G, and H, offer a mix of possibilities, from icy surfaces to thicker atmospheres that could support exotic weather patterns. The star's dimness and the planet's close orbits create a dynamic environment for atmospheric studies. Red dwarf stars like TRAPPIST-1 are known for their stellar activity, including flares and strong stellar winds, which can strip away planetary atmospheres over time. However, the planets' proximity to each other suggests that some might have shared atmospheres or even exchange atmospheric gases. This interplay could lead to unique chemical compositions and weather systems. Scientists are particularly interested in the potential for atmospheric biosignatures, such as oxygen, methane, or other gases that could indicate the presence of life. The James Webb Space Telescope and other advanced instruments are poised to delve deeper into these mysteries, offering unprecedented insights into the atmospheres of these distant worlds. The excitement surrounding the TRAPPIST-1 system is palpable, as it represents a rare opportunity to study multiple Earth-sized planets in a single system. Each world offers a different puzzle piece in the quest to understand planetary atmospheres and the potential for habitability. The system's compact layout and the star's unique properties provide a natural laboratory for testing theories about planetary formation, atmospheric evolution, and the conditions necessary for life. As our understanding of the TRAPPIST-1 system grows, so too does our appreciation for the diversity and complexity of planetary atmospheres, the breadth of life that could one day reveal the secrets of these distant worlds. The search for biosignatures, clues to life. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system has captivated astronomers and space enthusiasts alike. At its heart lies an ultra-cool dwarf star, barely larger than Jupiter, around which orbit 7 Earth-sized planets. 3 of these worlds, TRAPPIST-1e, F, and G, reside in the habitable zone, where conditions might allow for liquid water to exist on their surfaces. The system's compact nature means that all 7 planets are closer to their star than Mercury is to the Sun, yet the ultra-cool temperature of TRAPPIST-1 allows for temperate conditions on these planets. This unique setup has sparked intense interest in the search for biosignatures, those telltale signs of life that might be detectable in the planet's atmospheres. Each of the 7 planets in the TRAPPIST-1 system boasts distinct characteristics that make them compelling targets in the search for life. TRAPPIST-1b, the innermost planet, is likely tidally locked, with one side perpetually facing the star and the other in eternal night. Moving outward, TRAPPIST-1c and D also exhibit tidally locked rotations, but their proximity to the star suggests they might have atmospheres thick enough to redistribute heat. TRAPPIST-1e, the first in the habitable zone, is particularly exciting due to its Earth-like size and potential for surface water. Its neighbor, TRAPPIST-1f, is slightly larger and may have a water-rich composition, while TRAPPIST-1g, the largest of the 7, could possess a substantial atmosphere. The outer planets, TRAPPIST-1h, is likely to be an icy world, but its atmosphere could still hold clues to the system's history and potential for life. The search for biosignatures in the TRAPPIST-1 system hinges on the detection of specific molecules in the planet's atmospheres. Scientists are particularly interested in gases like oxygen, methane, and ozone, which on Earth are strongly linked to biological processes. The James Webb Space Telescope, JWST, with its advanced infrared capabilities, is poised to play a crucial role in this endeavor. By analyzing the light that passes through a planet's atmosphere as it transits its star, JWST can identify the unique spectral signatures of these molecules. The compact nature of the TRAPPIST-1 system makes it an ideal target for such observations, as the planet's frequent transits provide ample opportunities for study. The potential to find biosignatures in multiple worlds within a single system adds a layer of excitement. as it could reveal whether life is a common or rare phenomenon in the universe. The TRAPPIST-1 system offers a unique opportunity to study the atmospheres of potentially habitable worlds in detail. Each planet's proximity to its star and to each other means that their atmospheres can be studied in greater depth than those of more distant exoplanets. This could provide insights into the processes that shape planetary atmospheres and the conditions necessary for life to arise. The discovery of biosignatures in the TRAPPIST-1 system would be a groundbreaking achievement, potentially reshaping our understanding of life in the universe. It would also pave the way for future missions and studies aimed at uncovering the mysteries of these enigmatic worlds. The search for life beyond Earth has never been more thrilling, and the TRAPPIST-1 system stands at the forefront of this exhilarating journey. A tapestry of temperatures, from scorching to frozen. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system is a treasure trove of celestial wonders. At its heart lies an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets in a tightly packed orbital dance. This star system is a marvel of cosmic proximity, with the planets orbiting their star in a compact configuration, much closer than Mercury is to our Sun. The arrangement is so tight that a year on the outermost planet might last only about 90 Earth days. This proximity to their star creates a stunning gradient of temperatures, painting a vivid tapestry of conditions across the 7 worlds. The innermost planets, TRAPPIST-1b and TRAPPIST-1c, are bathed in intense stellar radiation. Temperatures on these worlds can soar, making them inhospitable to life as we know it. TRAPPIST-1b, the closest to the star, experiences extreme heat, with surface temperatures potentially high enough to vaporize water. Its neighbor, TRAPPIST-1c, is only slightly cooler but still far too hot for liquid water to exist on its surface. These planets are likely tidally locked, meaning one side perpetually faces the star, enduring scorching heat, while the other side remains in eternal darkness, possibly at freezing temperatures. The stark contrast between the two hemispheres creates a dramatic and extreme environment. Moving outward, the situation begins to change. TRAPPIST-1d, E, and F are the most intriguing planets in the system. They occupy the habitable zone, where temperatures could allow for liquid water to exist on their surfaces. TRAPPIST-1d is on the cooler edge of this zone, with temperatures that might be just right for vast oceans to cover its surface. TRAPPIST-1e is smack in the middle of the habitable zone, making it a prime candidate for further study. It could have a temperate climate, with conditions similar to those found on Earth. TRAPPIST-1f is on the warmer edge of the habitable zone, but it still holds the potential for liquid water, especially if it has a thick atmosphere to retain heat. These 3 planets are the most promising candidates for hosting life, and their diverse conditions offer a tantalizing glimpse into the possibilities of habitable worlds beyond our solar system. The outermost planets, TRAPPIST-1g and TRAPPIST-1h, present a stark contrast to their inner siblings. These worlds are likely much colder, with temperatures plummeting far below freezing. TRAPPIST-1g, while still within the system's orbit, receives significantly less heat from its star. It might have a thin atmosphere, allowing heat to escape easily. TRAPPIST-1h, the farthest from the star, is the coldest of the bunch. Its surface temperatures could be low enough to freeze even the most resilient of liquids. Despite their frigid conditions, these planets are not without interest. Their icy surfaces and potential subsurface oceans could harbor unique forms of life, adapted to thrive in extreme cold. The TRAPPIST-1 system, with its tapestry of temperatures, offers a fascinating glimpse into the diverse conditions that can exist within a single star system. Each planet, with its unique characteristics, contributes to the rich mosaic of this extraordinary cosmic neighborhood. The future of TRAPPIST-1, James Webb and beyond. Nestled in the constellation Aquarius, about 40 light-years from Earth, the TRAPPIST-1 system has captivated astronomers and space enthusiasts alike. At its heart lies an ultra-cool red dwarf star, barely larger than Jupiter, yet it hosts 7 Earth-sized planets, 3 of which orbit within the habitable zone where liquid water could exist. Each planet is tidally locked, meaning one side perpetually faces the star, while the other remains in eternal night. The innermost planets, TRAPPIST-1b and TRAPPIST-1c, are likely rocky and scorching hot, with surface temperatures soaring due to their proximity to the star. Moving outward, TRAPPIST-1d, E, and F reside in the habitable zone, with E and F being of particular interest due to their Earth-like sizes and potential for liquid water. The outer planets, TRAPPIST-1g, H, and the more recently discovered TRAPPIST-1i, are colder and may harbor icy surfaces or subsurface oceans. The James Webb Space Telescope, JWST, with its advanced infrared capabilities, is poised to revolutionize our understanding of the TRAPPIST-1 system. By analyzing the atmospheres of these planets, JWST can detect biosignatures, gases like oxygen, methane, and carbon dioxide that could indicate the presence of life. Each planet's atmosphere, if present, will be scrutinized for these telltale signs. For instance, TRAPPIST-1e, with its Earth-like density and size, is a prime candidate for hosting an atmosphere conducive to life. The telescope's spectrographs will dissect the light filtering through these atmospheres, revealing their composition and hinting at the conditions on the surface. This data could provide the first evidence of habitability or even active biological processes beyond our solar system. Beyond JWST, future missions and telescopes will delve even deeper into the mysteries of TRAPPIST-1. The upcoming Habitable Worlds Observatory, for example, aims to directly image exoplanets and study their atmospheres in unprecedented detail. This could allow scientists to map the surfaces of TRAPPIST-1's planets, identifying continents, oceans, and even potential vegetation. Additionally, advancements in space travel technology might one day enable probes to be sent to the TRAPPIST-1 system, providing direct observations and samples. The sheer number of potentially habitable worlds in one system makes TRAPPIST-1 an ideal laboratory for studying planetary formation, atmospheric dynamics, and the potential for extraterrestrial life. Each discovery brings us closer to answering the age-old question, are we alone in the universe? And there you have it, folks. 7 incredible worlds, each with its own unique characteristics, all orbiting a single, tiny star. TRAPPIST-1 is a treasure trove of possibilities, a cosmic laboratory right in our galactic backyard. From the scorching heat of TRAPPIST-1b to the chilly embrace of TRAPPIST-1h, each planet offers a different story, a different potential for discovery. Imagine standing on the surface of TRAPPIST-1e, a planet that might just have the right conditions for life as we know it. The sky would be a perpetual twilight, bathed in the dim light of its ultra-cool red dwarf star. The other planets would be visible, some as mere points of light, others large enough to make you feel like you're in a celestial ballet. This system is a testament to the incredible diversity of our universe. It's a place where we can test our theories, expand our knowledge, and perhaps, just perhaps, find that we are not alone. The TRAPPIST-1 system is more than just a collection of planets. It's a beacon of hope, a symbol of the endless possibilities that lie beyond our own solar system. So what's next? The James Webb Space Telescope is already on the case, ready to peer into the atmospheres of these distant worlds. Who knows what it might find? Maybe signs of life, maybe clues to the origins of our universe. One thing's for sure, the adventure is just beginning. We'd love to hear your thoughts. Which planet intrigues you the most? What do you hope we'll discover next? Share your thoughts in the comments below, and don't forget to like and subscribe for more cosmic journeys. Together, let's explore the wonders of our universe. The future of space exploration is here, and it's more exciting than ever. Stay tuned, stay curious, and keep looking up. The stars are waiting.